In pre-16 class, I wanted to give you three examples here of how holes work. Let's start off with a real kind of straightforward one. So these two things are virtually the same. Y equals x plus 2, we know how to draw that. It's a nice straight line. It has a y-intercept at 2, right? If I plug in 0 for x, I get y equal to 2. So my y-intercept is 0, 2. And if I set y equal to 0, I get 0 equal to x plus 2. And my x-intercept is x equal to -2, which is going to be -2, 0. So I've got that point there. I've got that point there. My graph looks like that if I don't move the paper too much when I graph it. Now, I'll also point out, just for the sake of knowing it, this graph also has the point 1, 3. If I plug in 1 for x, I get 3 for y. Okay, this other graph here, this other function, y equal to x squared plus x minus 2 over x minus 1. I just want to point out, in fact, let me call it f of x. So for f of x equal to x squared plus x minus 2 over x minus 1, f of 1 is undefined. It's 1 plus 1 minus 2 over 1 minus 1, which is 0 over 0. Here's what else I want you to see. This thing simplifies, right? I can rewrite x squared plus x minus 2. Well, that factors as x plus 2 times x minus 1 over x minus 1. I'm not going to cancel those just yet because there's something actually I want you all to see. So we can make a table. And for any x value other than 1, if we plug in y, or sorry, if we plug in x, we can see what the y value is. So notably, if I plug in, like x equal to 3, I'm going to get 5 times 2 over 2. Oh, the 2's cancel. I get 5. Or if I plug in 7, 7 plus 2 times 7 minus 1 over 7 minus 1. Oh, the 7 minus 1's cancel, and I get 9. What's actually going to happen is for any number I can plug in, I'm just going to get that number plus 2, because the x minus 1 over x minus 1 part, as long as it's not 0 over 0, cancels out. So if I plug in, x equal to 2.9, not really the number I wanted, but that's okay. I'm going to get 2 plus 2.9, so 4.9 times 0.9 divided by 0.9, and those cancel. And it works even for numbers that are really close to 2. Like if I plug in 2.1, I'm going to get, I want numbers close to 1 though, apologies. If I plug in 1.1, I'm going to get 1.1 plus 2 times 1 minus 1, 1.1 minus 1, which is 0.1, divided by 1.1 minus 1, which is 0.1. Those cancel and I get 3.1. And it works no matter how close the number is to 1. So I can pick a number like 1.00001. And when I plug that in, that number plus 2 is 3 point, lots of zeros, 1, 0, 0, 0, 0, 1, times 1.00001 minus 1 is 0.00001 divided by 0.00001. Oh, look, those cancel, right? They're not 0. Something divided by itself, as long as it's not 0, is equal to 1. So this is just equal to 3.00001. So hopefully this kind of shows you that for any value of x I pick, as long as it's not 1, the y value is just 2 plus that. And so if I pick values that are really, really close to 1, the y values are really, really close to 3. So what we're going to have happen here is when I graph this thing, well, we've already said it's undefined at 1. So whatever's happening at 1, this whole deal is undefined. But for the rest of it, it looks pretty much like y equals x plus 2, right? These cancel, and you get y equals x plus 2, right? Any x value we plugged in, we got the y value being 2 more. Plugged in 3, we got 5. We plugged in 7, we got 2. So what's going to happen is for any value that's not 1, we're going to get that number plus 2. So if I plug in 0, I get plus 2. If I plug in -1, plus 2 is 1. If I plug in -2, -2 plus 2 is 0. If I plug in 1.5, I get 2.5. Sorry, if I plug in, sorry, my brain is like, if I plug in 0.5, right, because that's 1, that's 2. If I plug in 0.5, I get 2.5. Plug in 0.9, I get 2. So I can pick values that are super duper close to 1. So everything except for at 1, I'm going to get this thing to be defined. But at 1 itself, we're going to have a hole. Right? Because it's undefined at 1. But we know that all the values around 1 are going to make the y values really, really close to 3, right? Like if we plug in 1.0001, oh, the y value is going to be 3.0001. Sorry, I'm showing you a thing right over here. Or I plug in 0.999. If I plug that in, I'm going to get 2.999. So when I pick values that are super duper close to 1, I get y values that are super duper close to 3. That's why there's a hole there, because it's undefined at that one point, but everywhere around it, it's still just kind of how it would normally look. So the way to deal with this is when you see something like this, you cancel the factors, you rewrite it as f of x equal to x plus 2, and you remind yourself, oh, x is not allowed to equal 1. Or better yet, just tell yourself, I have a hole at x equal to 1. Let's do 2 more examples. A little bit tougher, but not really. So I'm going to do y over x, 1 over x plus 1 versus x plus 3 over x squared plus 4x plus 3. So this one, we could still graph in the usual way. It's got a, let's see, the y-intercept is going to be 1. So if I plug in x equal to 0, I get y equal to 1. I don't have any x-intercepts because if I set the top equal to 0, or if I set the whole thing equal to 0, there's no solution. So none. My vertical asymptote, I set the bottom equal to 0, I get x plus 1 equal to 0, so I get x equal to -1. And finally, for my horizontal asymptote, since the degree on top is less, we know it's going to be 0. So graphing this, right, really I'm just taking the 1 over x graph and shifting it 1 to the left. So there's something that I think is probably not in the way, but I'm going to move it anyway to see if it's not in your way. So I'm going to shift this 1 to the left. There's my vertical asymptote at x equals -1. My y-intercept at x equal to +1. I don't really need to make the sign chart, though we totally could, right? You can see hopefully that if x is bigger than -1, like if x is 0, it's positive, and if it's anywhere bigger than 0 or bigger than -1, it's going to be positive. And then horizontal asymptote. And if x is less than -1, like -2, this whole thing is going to be negative. When you plug in -2 specifically, you get -1, which is kind of a typical point to plug. Okay, so that's what that looks like. The only difference between this and the other graph, well, actually, let's take a look at the other graph. So this one, I'm going to factor, and I'm going to call this g of x. G of x equals x plus 3 over x plus 3 times x plus 1. So as long as x isn't -3, this whole thing is perfectly fine. But if x is -3, you get 0 over 0. So I'm going to say, oh, g of x is equal to 1 over x plus 1, but we know there's a hole at x equal to -3. Right? Everywhere close to -3, just like the previous problem, right? If you pick a number like, -2.999, if we plug that in, g of -2.999, check it out, is going to be -2.999 divided by, sorry, -2.999 plus 3, which is a very small number, divided by -2.999 plus 3. Oh, look, those are the same. They cancel out. And then -2.999 plus 1. Those cancel. You get a number that's equal to 1 over -2.999 plus 1 is going to be -1.999. And that is very, very close to -1/2. Which is what you would get if you actually plugged in -3, right? If you plugged in -3 of this function, you get 1 over -2, which is -1/2. So this point here that's on this graph, which is -3, -1/2, is going to be the hole that we have on the other graph, right? Because we can't plug in -3 there, but anywhere around -3, it's very, very close to -1/2. So the other function, So this is y equal to 1 over x plus 1. This one's going to be g of x equal to x plus 3 over x squared plus 4x plus 3. Literally the same graph, just that there's going to be a hole at that point right there. So I'm still going to get the point 0, 1. I'm still going to have my vertical asymptote be -1. And then I'm going to have, I would have had, right, sorry, I got that point there. And then I would have had -3, -1/2, I'm going to have a hole there instead. But then everything else looks exactly the same. I'm trying to make that look like that looks good, cool. And then up here, comes down like that. Same graph, except this one has a hole at -3, -1/2. Okay, one more example. Where'd you go? Yeah, this one's a little more complicated, but not too terribly complicated. So here's a graph: y equals x minus 2 over x plus 4 versus y equals x minus 2 squared over x minus 2 times x plus 4. So here we have, let's just do the graph. So we're going to have y intercept, we're going to set x equal to 0. We're going to get y equal to -2 over 4, which is -1/2. X intercept, you're going to set x minus 2 equal to 0. You're going to get x equal to 2. Vertical asymptote, set the bottom equal to 0. You get x equal to -4. And then horizontal asymptote, since the degrees are the same, right? Degree on top is 1, degree on the bottom is 1. The horizontal asymptote, again, I want to make this super extra clear for everybody, right? It's the quotient of those coefficients. So the horizontal asymptote is y equal to 1 over 1. It's not because the degrees are 1, although it is important that the degrees are the same. It's because since the degrees are the same, the quotient of the coefficients is 1 over 1, which is 1. Great, we can graph this. So let's see, I've got 0, -1/2 as my y-intercept. I've got x equal to +2 as my x-intercept. It's going to cross there because the x minus 2 came from a power of 1, although I'm going to just do it the other way. -4 is my vertical asymptote. A little more negative than I intended, but that's all right. Sorry, this might be kind of off the page here, apologies. My horizontal asymptote is y equals to 1. Okay, so I suppose I can make a sign chart as well. So the important values on my sign chart are always the x values, meaning the x-intercepts and the vertical asymptotes. Pick a number larger than 2, like 3, plug it in. 3 minus 2 is positive, 3 plus 4 is positive, so it's positive over positive. And then between -4 and 2, like 0, always choose 0 if it's an option. When we plugged in 0, we got y equal to -1/2, so it's going to be negative. And then over here on the other side, -4, like -5. You plug in -5. -5 minus 2 is negative. -5 plus 4 is negative. Negative divided by a negative is positive. So it's going to be something like this. It's going to be positive over here. Sorry, I'm not really displaying my horizontal asymptote behavior very well, though, but it would just get closer and closer as we went out that way. And then it's negative from here to here. So it's going to be down this way. We're going to come up. We're going to hit that point. We're going to continue on. We're going to hit that point, and we're going to go through it and become positive. Get closer and closer to the horizontal asymptote, like that. The only difference between this graph and the graph of this is that, and the graph of this is that this one is going to be undefined at 2. So we're going to have a hole at x equal to 2, which happens to be where this one had an x-intercept. So specifically, our hole is going to be at the point 2, 0. We can rewrite this, right? We can write this as y equal to x minus 2 over x plus 4, but x can't equal 2. Because all we're doing is canceling out one factor of x minus 2 on the top, one factor of x minus 2 on the bottom. And so when we do this, I'm going to try and graph this one a little bit nicer, although I'm kind of don't have a ton of room here. Sorry, it's not the best looking I've ever done. Apologies. So I'm going to make this a little bit smaller just to make so you can see it. So here's my vertical asymptote at -4. Here's my horizontal asymptote at y equals 1. my y-intercept at -1/2. And what would be my x-intercept at +2, but I know it's going to be a hole there. And then it's literally just going to be the same graph. So it's going to be, out this way, coming up like that. And then it's down over here, and then I'm going to come up just the same way as before. Hole there, like that. So when you cancel a factor on the top and the bottom, like x -2, that means x -2 can't equal 0 anymore because you'd have 0 divided by 0, or x can't equal 2. That's why we have a hole when x is 2, which at this point is 0.20. So hopefully that makes the holes a little more clear. They're not like a huge deal, but they are something that people had questions about. So I wanted to make sure that there was examples of what's going on with holes. All right, take it easy. I'll see you guys next time.